Okay, so let's get right into it. For 20 years, solid-state batteries were always the next big thing. You know the story, perpetually 5 years away. And then, bam, January 2026 happened. Something the entire industry said was basically impossible. Just shipped.
And I want to be really clear here. What you're looking at isn't some lab prototype or a concept car spinning on a platform. This is the Verge TS Pro motorcycle. It's on public roads, and customer deliveries are starting now. A technology that was supposed to take, I don't know, the rest of the decade to figure out is suddenly here.
You know, for 2 decades, solid-state was the holy grail of storing energy. The idea was simple: make batteries that are safer, pack more punch, and last way longer. But every single major company that went after it just hit a wall. So when the breakthrough finally happened, it didn't come from anywhere you'd expect.
Which brings us right to the heart of this thing, the central mystery of the impossible motorcycle.
So you've got this small Finnish startup, Verge Motorcycles, working with a little tech company called Donut Lab. And they just delivered a technology that these industrial giants are still, years away from getting to market. So the questions are pretty obvious, right? Why now? And how in the world did a niche motorcycle company get there first?
This gets us to what you could call the Toyota paradox. I mean, think about it. Toyota holds more patents in solid-state tech than any other company on the planet. Their own official target for rolling this out is 2027, maybe 2028. And yet, Verge is shipping vehicles with this tech today. Now, this isn't a story about a big company failing. It's a really fascinating engineering puzzle. And to understand the answer, we first have to understand the problem they were all facing. For decades, solid-state batteries failed, over and over again. And they failed for these brutal, physical reasons. This is the story of the walls that everyone else slammed into. So, real quick, what even is a solid-state battery? In the simplest terms, you take a normal lithium-ion battery and you get rid of that flammable liquid inside, the electrolyte, and you replace it with a solid material, something like a ceramic. The promise is huge: more energy in less space, and you remove the main thing that causes battery fires. Sounds great, right? But in practice, it's been nearly impossible to pull off.
The failures, well, they really came down to 3 fundamental walls. First up, anode expansion. To get that crazy energy density, you have to use a pure lithium metal anode. But as it charges and discharges, it physically swells and shrinks. It literally breathes. Second, this creates a massive problem with interface resistance. You know, unlike a liquid that perfectly coats a surface, you've got a solid pressing against a solid, and the contact is terrible. And third, dendrite growth. These tiny, needle-like spears of lithium start to grow, and they eventually just pierce right through the solid separator, short-circuiting and killing the cell for good. So this is the core mechanical problem. You've got the anode breathing, expanding, and contracting, but it's pressed up against this brittle ceramic separator. This constant stress creates tiny, microscopic cracks in that solid electrolyte. And once that happens, you lose contact, resistance goes through the roof, and the battery's dead. It mechanically tears itself apart from the inside out.
And this is the absolute key takeaway. For years, the world's best chemists were trying to solve this by inventing some perfect, magical new material. But they were attacking the wrong problem. The issue was never just about the chemistry. It was a problem of physics and mechanical engineering. And that shift in thinking, well, that's what finally led to the breakthrough, the mechanical solution. Okay, so if the battery is literally destroying itself mechanically, what's the engineering fix? How do you actually stop it from tearing itself apart?
The breakthrough was to stop treating the battery like it's just a simple container for chemicals, and start treating it like a machine where the physical forces, specifically pressure, have to be actively managed and controlled all the time.
So how did Donut Lab actually do it? Well, instead of trying to invent some new miracle material, they engineered a whole new system. They use a flat plate-based design, which is super important because it lets them apply a constant active mechanical pressure across the whole cell. Think of it like a clamp. This external force physically fights back against that internal breathing of the anode. And by controlling that pressure, they can maintain perfect contact between the layers, which stops those cracks from forming and prevents those killer dendrites from growing.
So really, when you boil it all down, they didn't invent some magical new battery chemistry. What they did was invent an engineering system to keep a really high-performance solid-state battery alive and stable for thousands of cycles. And just keeping it alive, well, that unlocks a whole cascade of incredible real-world advantages.
Yeah, compared to the lithium-ion batteries we all use today, the benefits are pretty profound. For starters, you get rid of the flammable liquid, which is the root cause of those thermal runaway fires. You get way better performance in the cold,
Donut Lab is claiming over 99% capacity, even at -30 Celsius. And because you're not beating up the cell with every cycle, the potential for extreme longevity completely changes the whole economic picture. Now, a breakthrough this big doesn't just stay in a vehicle. It sends a global shockwave that ripples right through supply chains and even geopolitics.
Here's why governments are suddenly paying very close attention. The lithium-ion batteries we use now absolutely depend on graphite for their anodes. And today, China dominates the processing of that specific battery-grade graphite. But solid-state batteries, because they use a pure lithium metal anode, completely bypass the need for graphite altogether. Now, that doesn't solve all our supply chain problems, but it does create a pretty significant potential to rebalance who holds the leverage over critical minerals.
But, when you make claims this extraordinary, you are going to attract some serious controversy. And sure enough, shortly after the announcement, the CEO of Svolt Energy, that's the top 10 global battery maker, publicly called the claims a potential scam, saying the numbers were contradictory and that any technician would recognize it.
And look, this isn't just a competitor being salty. The expert community is asking some legitimate, really hard questions. Like, how exactly are you defining and testing a 100,000 cycle life? What about calendar aging? How does the battery degrade just sitting on a shelf for a few years? Can this complex mechanical system really be manufactured at a huge scale with good quality control? And maybe the biggest question of all, where's the independent, third-party validation?
So let's just be very clear about this. This could still fail. The jump from a small production line in Finland to mass market scale is a gigantic challenge, and we have seen very promising battery technologies stumble at this exact stage before.
Which leads us to our final act, what comes next?
This timeline really puts the whole Verge and Donut Lab launch into some pretty stark context. While they're claiming to be delivering vehicles right now, in the first quarter of 2026, you've got the giants like Samsung and Toyota still targeting 2027 and 2028 just for their first commercial rollouts. It is an incredibly ambitious lead, to say the least.
So the most likely way this plays out is that it'll start in niche, high-performance areas where cost isn't the main concern. Think premium motorcycles, military drones, specialized vehicles. Getting this into a mass market car will be a much tougher challenge. But no matter what happens, this moment is huge. It represents the first credible, shipping, commercial alternative to lithium-ion chemistry's dominance in over 30 years.
And that leaves us with one final, kind of provocative thought. For the entire history of electric vehicles, we've always treated the battery as a consumable part, something with a limited lifespan. But what if that completely changed? What if a battery wasn't something you replace, but a permanent asset that could very well outlast the vehicle it was built into? That's the paradigm shift this technology really represents.